just so you all know, this is my last recording for this bit of absence, and I could not be more excited. I'm very tired of talking to myself. Believe it or not, I actually enjoy having you in class. Just kidding. All right, bell assignment. Work on it on your own, at your own seat. Whenever you're finished, please put your answers on the board. Pause it so that it stays up there while they're working. What we're talking about today is lesson 64, inverse variation. Okay, recall that we already talked about direct variation between two variables, which is y equals kx, where k is that constant of variation. Okay, inverse variation is a relationship between two variables whose product is a constant. So the two variables are still x and y. Product means we're multiplying them. So inverse variation is xy equals k or y equals k over x. And k still is the constant of variation. So k is still going to be a constant. It's going to be a number. When they want to know the constant, it's that number. We say this, y varies inversely with x. Tell whether each relationship is an inverse variation. Well, we know that for it to be an inverse variation, it can look like two different equations. It can be xy equals k, or, it can be y equals k over x. So we may have to manipulate these a little bit to see if we can get them in one of these forms. On A, I want to get x and y on the same side. So to get x and y on the same side, I'm going to have to move the y. Right now the y is dividing into that 36, so the opposite of dividing is to multiply. So what I do to one side, I must do to the other. Y and y will cancel, leaving me with xy equals 36. So is this inverse variation? Why, yes it is. And what is that constant? That 36. Okay. On B, wants to know the same thing, so I need to get either xy on the same side or get it as y equals k over x. To get x and y on the same side, y right now is on the top, so the opposite is going to be to divide by y, so I can put 1 over y. Same thing over here. Cancels. I'm left with 1 over 12 equals x over y, because this is x over 1 times 1 over y. I have x and y on the same side. They're not being multiplied though, they're being divided. So that means that this is not inverse variation. Okay? Product rule for inverse variation, and this is the most common way that you're going to have to use inverse variation, is the product rule. And the product rule is this: if x1, y1 and x2, y2 are solutions of inverse variation, then x1, y1 equals x2, y2. That means if you take x and y from the first coordinate and you multiply it by x and y of the second coordinate, it has to be equal to each other. So if y varies inversely as x and y equals 5 when x equals 12, find x when y equals 3. So these two go together, and then we want to find it when this is the case. So we're going to call this x1, y1. We're looking for x2 when this is y2. So my equation is x1, y1 equals x2, y2. Instead of x1, I'm going to plug in my 12. Instead of y1, I'm going to plug in my 5. Equals my x2, which I don't know, times my y2, which is 3. So 12 times 5 gives me 60. 3 times x sub 2 is 3x sub 2. To get x by itself, I'm going to divide by 3. What I do to one side, I have to do to the other. So I get that x sub 2 equals 20. Okay. I want you to try and do B on your own paper. Please pause the video for a minute until they're done. Okay, on B it says if y varies inversely as x and y equals 3 when x equals 12, find x when y is 9. So I have my x1, y1, and x2, y2, and I only put these up above here because I didn't have room. Okay, so my x1, y1 has to equal my x2, y2 again. My x1 is 12, my y1 is 3, and that has to be equal to x2, which I don't know, and y2, which is 9. So 12 times 3 is 36, equals 9 times x2 is 9x2. To get x by itself, divide by 9 on both sides. I'm left with x sub 2 equals 4. Final answer. Write an inverse variation relating x and y when x is 2 and y is 6. Then graph the relationship. So I know that inverse variation has to be xy equals k or y equals k over x. So if they give me x and y and they want me to write a relationship, I'm going to just plug them in here and find that k. So instead of x, I'll plug in 2. Instead of y, I'll plug in 6. That has to be equal to k. 2 times 6 is 12 equals k. Now, to do this graphing the relationship bit, I have to take 12 and plug it in for k. So I have y equals 12 over x. In order for you to graph this, you're going to need to make a t-chart. So I have x and I have y. Here's my t-chart. Now look at where x is here. I want to be smart about the way that I do this. Okay, in order for me to do this, I want to pick numbers that'll divide into 12 evenly and easily, so it's less work for me. I don't want to deal with a bunch of decimals and fractions. So numbers that will divide into 12 easily are 1, 2, 3, 4, 6. We'll just go with that. So if I plug in 1 for x, this is the first part, I'm going to put 12 over 1, that gets me 12. If I put 12 over 2, that gets me 6. 12 over 3, that will get me 4. 12 over 4 gets me 3. And 12 over 6 gets me 2. So, whenever I do this, hold on just a second. Okay, I'm back here. We're also going to have to do the opposite side because we're going to have to graph this on a coordinate plane. Okay, so whenever we do that, we need to do the negatives also. So let's go ahead and plug in 0 here, and then we'll do just -2, -4, -6, okay? And if I plug in 0 for x, I have 12 over 0. What is 12 divided by 0? What is anything divided by 0? Anything being divided by 0 is undefined. Don't forget that, okay? So that means that we can't graph a point at 0 because it can't happen, okay? -2, if I plug in -2, 12 divided by -2 is going to give me a -6. 12 divided by -4 gives me a -3. And 6 going in there will give me a -2. So now I have my points, my coordinate plane here. Okay, so here's my coordinate plane. And my first point is at 1, 12. So I'm going to go over 1, up 12. There's my first point. Next point is at 2, 6. Over 2, up 6. 1, 2, 3, 4, 5, and 6. Next point, 3, 4. Over 3, up 4. Next point is at 4, 3. So I'm going to go over 4, up 3. Next point is at 6, 2. So over 6, 3, 6, up 2, right there. Okay, so you can see that this part of the graph goes like this. Okay. Now at 0 it's undefined. We show it is getting closer and closer here on this end, but it's never going to go through that 0. It'll get as close as possible, but it will never go through 0 because it's undefined there. We do not know. The other side, we have -2, -6, so I'm going to go left 2, down 6, 2, 4, 6. The next one is -4, -3. And finally, we have -6, -2. So this side of the graph goes like this. This is our graph whenever we're talking about inverse variation. If Maria is riding her bike at a rate of 12 miles per hour, it will take her 1 3/4 hours to reach her destination. How long will it take her if she travels at a rate of 18 miles per hour? So once again, we have x and y, and we have to use that product rule, okay? So I know that my product rule is x1, y1 equals x2, y2. So whenever we have this, I know that my rate here, I'm going to say that this is my y1, this is my x1. So this has to be y2, and I'm looking for x2. So instead of x sub 1, I plug in 1 3/4 or 1.75 because I'm lazy and like to punch it in my calculator. And then I have 12 for y sub 1 equals, I don't know, x sub 2, and then I have 18 for y sub 2. Now whenever I do this, all I have to do is that multiplication, so 1.75 times 12 gets me 21 equals 18 x sub 2. To get x sub 2 by itself, I have to divide by 18 on both sides. So I have that x sub 2 equals 21 divided by 18, which gets me a 1.16 with the 6 repeating. Okay. The decimal portion of that, the 1.6 with the 6 repeating, that is actually equal to 1/6. So let me see here. We'll rewrite this as 1 1/6, and our label for that would be hours. Is that x sub 2? I'll take either one. I know that you know what you mean. Okay. For your homework on this, I want you to do the practice set. Okay, the A through whatever, and the rest of what's listed here. Okay, that's your homework. It will be due tomorrow. You need to be working quietly and individually for the rest of the hour. Be good. Make sure the assignment gets put on the assignment board.